Hello everyone, thank you for taking time to watch this video. Today we are going to learn about incorporating your own data with large learning models. So what I mean by that is that the chat gpt and google gemini, these large learning models, they are very good with conversation english. What they have done, they have scanned the internet or all the data that's openly available, and they have processed the data and understood how the sentences are being formed. So it looks very good when you talk to the computer through ChatGPT or Google Gemini and all other learning models that's out there. But they can only talk the generic subject. What I mean by that is it's about the knowledge base that's out available in the internet or in the open systems. These models have been trained in that knowledge and they can share some information. But let's say you want the learning model to access your company's data. So let's assume you are an insurance company and your insurance policy holder, logs into the chat window and ask a question about their policy and say, what is my home premium for next month? Now, what you can do is you can retrieve the data that is very specific for this one customer and give it to the learning model, and the learning model can respond like a human being in a conversation, and it could say, hello, good morning, customer xyz. Thank you for being our loyal customer. For the next month, this is your premium. It can give that value that's precisely augmented for that one customer. And to do this kind of work, we need to understand two things that are embedding as well as RAG, that is retrieval augmented generation. So that's what we are going to see in this video today. Now, as you know, most of you would already know that we have learning models like OpenAI and Google's AI, that's Gemini. I would highly recommend, if you have not already played with these models, please register yourself in these websites and use the free version and try asking many questions to these data models. And it's pretty interesting what answers they could come up with. Um, you can ask them to write a poem, you can ask them to, uh, you know, explain certain concept to you. It's pretty interesting. Now, on the downside, they can make up an answer for you, because they are creative. Even when they don't know the actual answer, they could make up some things. And I have seen articles written by these learning models that have wrong information. So be mindful of that. But these are very powerful tools and they are here to stay. Now, embedding is a concept where you represent a word using some number, and that those numbers represent the context of the word. If you say hello, how are you, hello and how, they are used in greetings and they normally come next to each other, right? Similarly, it's a context of these words. It's not the grammar, more than that, it's a context where they fit in all these documents. Is known as embedding, and they are represented using a number. And RAG is the concept where you take your own data, your enterprise's data, and make it as part of the large learning models uh, interaction. And now, to discuss about embeddings, take this example. So let's say you ask few people about one specific tourist location and ask them to rank it from 1 to 10 about cost. What's their opinion? And then you ask them to explain about the historical importance, whether it's historically very important, or it's not. And now in this graph you have two scales, and depending on the score you get, now you can create a vector and it will show you in this two dimension where the ranking falls, right? Now let's assume you add another dimension to it, and it could be the expense. How expensive is this place? Is it very expensive or not? And that could be the third dimension. And you can keep adding dimension to this graph, and the vector, now it gives you the context. Depending on the dimensions that you have here, the vector is defined, and now you have a number. Now let's say you have two such vectors, you can combine them with cosine similarity. And if both the vectors are exactly the same in the dimension, they will fall exactly one over other. If it's totally opposite, it's like 180 degrees, it's totally opposite. Or you will find an angle that will show you how similar they are. And this is the concept of embedding. You have some dimensions, and within the dimensions now you can find a number, a numeric value that represents the vector. So let me go to my next slide. So in GPT-4, the recent model, they have 3072 dimensions used. So anytime you pass a word or a sentence to this GPT model and ask for the embedding vector, it'll actually give you these 3072 values. And those are numbers. The value doesn't represent much. You can't make a meaning out of the individual numbers, but they show their position or context within all those dimensions put together. So you can't just look at a number alone and it wouldn't mean anything. Um, but as I showed previously, how you can compare different vectors, um, the, you know, these numbers help you to quickly compare two sentences or two words within the context of these 3072 dimensions, how well they align. So that's how the search and retrieval is fast, because you're combining these numbers and checking how it is being done. Um, Now, if we write code, with a for loop of doing these comparisons, it'll take a long time. But the specialized GPUs that are used by these systems nowadays, they are optimized to use hardware accelerated numerical processing. So they process these numbers using the inbuilt hardware specialized capabilities, and these GPUs are very powerful nowadays. If you go to AWS or any of the cloud providers and start allocating these GPUs, you can see they don't come very cheap either. Some of them could be very expensive. So when you configure some of these systems in your test environment or production, be mindful of the cost. It could lead to some surprises. So but these GPUs are specialized system, and without these GPUs, processing million vectors is not going to be easy. So you do need that computing power. You need to balance that with the cost. Um, Now, there are some specialized databases out there where you can save these vectors and do a search of nearest neighbor kind of search. The traditional databases like SQL Server, MongoDB, these are also starting to uh, provide these functionalities. MongoDB, traditionally, it's a document database where you can save a lot of JSONs and process them. Neo4j is a graph database. It already had some graph. Uh, you know, it has graph. It's a graph database where you can store nodes and the vectors already inside. So they are also getting into this vector database business. MongoDB is getting into it. SQL Server is also trying to adapt. Pinecone is a specialized database for vector databases. And obviously, when you are trying to compare large volume of documents or information, you would need something specialized for your system. So these are vector database where you save large number of vectors. Now, what is RAG? I already said, you know, RAG is used for augmenting the learning model with your own enterprise data. Now, why do we need RAG? Now, the the GPT-4, if I remember correctly, it is trained with 2021 data. They added more dimensions recently, but it's still trained with 2021 data, 21 or any data prior to that that they could find on the internet and the open sources. So the data is not up to date within the learning model. Okay. Now, your customer data or anything that's specific to your organization is not exposed to the learning model. So the learning model has no idea about your customers or your enterprise data. Now, AI can make up stuff. That's a scary part. When you use for enterprise use cases, AI should be accurate. It cannot make up stuff, and we should prevent it in all possible ways. And RAG gives you an option to restrict the response that is given by LLM. Uh, Obviously, when you provide your own data and tell learning model to use only the data, you are increasing the accuracy of the data or the response that is received from the LLM. Um, it gives you option to provide up to date data, right? The LLM might have had access to some policy or law that has been created before 2021. But if the law got updated recently, now you can provide the most recent document to the learning model and say, okay, now depending on using this new rules and regulations displayed in this uh, document, you generate your response. So there are many use cases and why we should use RAG. And now let's see how to implement it. The first and foremost, what you do is you collect all your documents and your own data in your company and you embed them by using the learning model. So let's assume, back to you're an insurance company, you have your insurance declaration deck. That's a pretty big document. Every time you get a home insurance, they send you a deck. And I used to work for an insurance company, and we used to joke that that's a least read document in the world. I don't know that's true or not, but most people don't read the declaration end to end. But let's say you have the document in your company and you feed it into, you want to convert that into the vector and save it in your database. Now, most of the learning models today, they have a size limitation. So you cannot send the whole document into the LLM and say, embed this for me. Rather, you have to cut it into chunks, smaller pieces, and then send it to it. Now, chunking introduced some kind of problems because let's assume um, you are one big insurance company, but within that, you have a company registered in New York and you have another company registered in Pennsylvania, and the rules are a little different. The declaration statements are a little different for each state. And your your document starts with XYZ Insurance Company of New York, and it explains everything. And you have another document, pretty much similar, but with few minor changes. But that starts with XYZ Insurance Company of Pennsylvania. So let's say you feed the first page as the first chunk. everything is well and good. But in the second page, your statement may start as, in this organization, this is how this policy is implemented. And in the that's for New York. And for Pennsylvania, you may have the same thing. So when you pass in the second page, the LLM will not be able to differentiate whether it is New York or it is Pennsylvania. So when you have a large document, when you chunk it, you need to make sure you don't have these kinds of problems that exist. But in general, the concept is you take your large document, you chunk it into pieces, you feed it to your LLM, and get the vector, all the embeddings for the dimensions that they have within the LLM, you generate it and you save it in your vector database. So that's your ingestion phase. You have to have your own vector database created for all the data that might be used in the future. And then let's assume a user logs into your system and they are asking a question. In this case, you have an insurance customer who's asking a question. um, Hello, company XYZ, what is going to my home premium for next month? Now, that itself is an English sentence. So you take that and you embed it. You get the translation from your LLM and you get your big vector. In this case, 3,000 different numbers you'll receive it from ChatGPT. And then using this new vector that you received, you compare the data that you have saved within your database. Now you have in your database the vector for all your policies that has already been created and it is saved in your database. So, what we'll do next is to retrieve documents that are, maybe the top five that's relevant to the vector that represents the question. So, you have a vector that represents the question. You have a lot of vectors saved in the database. You find the top five matching. And then you give that to the LLM, the top five matching vectors. And the LLM will use this information and you can instruct it how you want to generate the answer. And the LLM will then formulate the response. Now it will be in a well formed uh, English text. So it can say, hello, customer, XYZ, as per our home insurance policy, next month your premium is, some amount, and then the deductible is being increased because you updated your policy last month. So all these conversation kind of information. uh, So the core data is coming from your vector database, but LLM is appending that with conversation style English. And once the response has been formulated, it'll send the data back to the user query. And now the end user has an option to receive an English style, a conversation style response. And this is key in incorporating your own data, your enterprise data, and augment that with the response of a learning model. And I have some reference to the learning model itself, and there's a interesting tool for understanding how tokenization of strings work, and also Neo4j, how you can use it for a RAG. In my company, I'm actually working on a project where we are using Neo4j for RAG. And, there's a video explaining about tokenization. So, thank you very much for listening to me. I hope this was helpful. Um, Please let me know if you have any questions. I'll be glad to help you with the answers. Thank you. Have a good one. Bye.